Well, the present lecture is the fourth lecture of vector, and we have seen in the previous three lectures the basic meaning of vector, the representation of vector, the negative of a vector, how vectors are added by Polygon law, how the vectors give a zero resultant. And I recommend you, before watching this lecture, please go through the three lectures of vectors, the link of which are given below in the description. Okay. Now, see, in the present lecture, let us see the roadmap, how we are going to explore the first present lecture. First of all, we will see the Polygon law analytical method, how we calculate the resultant vector in Polygon law. Then we will see a special case of Polygon law, that is the triangle law. We all know triangle is a polygon with three sides. So triangle is nothing but a special case of polygon. Then we will see some of the basic properties of triangle, which will be useful in solving vector problems geometrically. Then we will see what will be the resultant of two vectors with equal magnitudes. If we have two vectors with equal magnitudes, then how the resultant will come. And then we'll see a special case when two vectors are equal magnitude and the resultant is also of same magnitude, then what will be the condition for it? Two vectors are of same magnitude and the resultant of the two vectors will also have the same magnitude. So this is the roadmap of the present lecture. Okay. Now let's see, already we have seen what is the meaning of magnitude of a vector. So geometrically, the magnitude of a vector is the length of the side representing that vector, correct? Length of the side representing that vector. So what it means, suppose this is a triangle, okay? This is a triangle, and say this is your vector A, this is vector B, and this is a vector C. Say this is OAB. And suppose we have to find the length of the side OB. So see, the side OB is representing the vector C, correct? The side OB is representing what? Vector C. So when you write the magnitude of vector C, we can write like this. If you remember in lecture 1, modulus of vector C or simply C. So it will be the side OB, correct? So geometrically, if you have to find the magnitude of vector C, simply find the length OB, correct? Geometrically, if you have to find vector C, magnitude of vector C, simply find the length OB. So the magnitude of a vector is the length of the side representing the vector. And how we will find the length of the side? By applying the basic geometry, by applying the basic theorems, the basic properties of geometry, okay? Now let's see how we can find the direction of a vector. Now see, geometrically, the direction of a vector means the orientation of the vector. Geometrically, the direction of the vector means the orientation of the vector. Now what is orientation? It means the angle subtended by the vector with some known vector, angle subtended by the vector with some known vector or known direction or known axis. Okay. So suppose there is vector R. Suppose we have a vector R and the tail of vector R is coinciding with the tail of vector A, and this angle is alpha. So you can say vector R is subtending an angle of alpha with vector A. So in this case, vector R is subtending some angle with a known vector, correct? With a known vector. Okay, instead of a known vector, it can be some direction. Suppose this is your east, and this is your vector R, and this is alpha. So you can say vector R is subtending an angle alpha with the direction of east, or instead of some vector or direction, it can be some axis. Suppose this is your x-axis, and this is vector R, and this is angle alpha. So you can say vector R is subtending an angle alpha with the x-axis. Okay. So I hope you are clear to what is the meaning of direction of a vector. The direction of a vector means the angle subtended by the vector, with some known vector or with some known direction or with some known axis. So like in this figure, you have seen, if you want to find the magnitude of vector C, then you have to find the length OB. And suppose if you have to find the direction of vector C, so for finding the direction, you need to determine the angle. So in this figure, vector C and vector A are tail to tail. So let this angle be alpha. So alpha denotes the direction of vector C. Vector C is making angle alpha with vector A. And C and B are head to head. If this angle is beta, so vector C is subtending angle beta with vector B. You know, when the vectors are tail to tail or head to head, the smaller angle is the vector angle. So this is the meaning of direction of a vector. Got it? So you can note it down. What is the significance and method for finding the magnitude and direction of a vector? Magnitude means length of the side and direction means the angle made by the vector. Now see, magnitude of sum of vectors and sum of magnitude of vectors. See, when vectors are added, they do not follow arithmetic. They follow different laws. Basically, they are added geometrically. They are added geometrically. So if you are adding forces, suppose a box is acted upon by two forces, say F1 and F2, and say the magnitude of F1 is 8 Newton and the magnitude of F2 is 10 Newton, correct? And let F be the resultant force. F is the resultant force. So we have already seen the notation of writing. We can write vector F is the sum of two vectors, F1 and F2, correct? Now, this equation is saying vector F is the sum of two vectors, correct? Vector F is the sum of two vectors. Now, if you add by simple rules of mathematics, so the sum of the magnitude will be 10 plus 8. 10 plus 8, that is how much? 18. So when you write sum of magnitude of vectors, okay, sum of magnitude of vectors. So we will take the magnitude, say modulus of F1 plus modulus of F2. This is the meaning of sum of magnitude. Okay, this is simple arithmetic addition, nothing else. You will take both the magnitude and add up. So modulus of F1 will be 8 Newton plus 10 Newton. So you will have an answer how much? 18 Newton. This will be the answer for the sum of the magnitude. There is no vector addition in this case. We are not dealing with any vector addition. They are added arithmetically. But when you are writing this thing, modulus F1 plus F2, so see what are you doing? You are adding the vectors first. Sum of vectors. And then you are taking the magnitude. So this is called magnitude of sum of vectors. Okay, both carry different meaning. And if you see in vector maths, the meaning of magnitude of the sum of vector is not same as the meaning of sum of the magnitude of vectors. Okay, they are not same in meaning. What is the difference? LHS is telling you the magnitude of the sum of vectors, and vectors are added geometrically. Right now I will illustrate one example which will make it more clear. The vectors are added geometrically. So first we will add the vectors, then we will take the magnitude. On LHS, what you're doing, first you are adding up the vectors, then you are taking the magnitude. On RHS, what you're doing, you are taking the individual magnitude and then you are adding the magnitudes. So this is denoting the magnitude of the sum of vectors, magnitude of the sum of vectors, and this is denoting the sum of magnitude of vectors. Now let's see one illustration which will make it more clear. We know displacement is a vector quantity, right? We all know displacement is a vector quantity. Now suppose you are standing at a point O and you walked 4 kilometers till a point A. This is your displacement A, vector A. Then you took a perpendicular turn. From A, you took a perpendicular turn, okay? and you walked up to a point B covering a displacement vector B of 3 kilometer, correct? So initially you were here at a point O and finally you are at a point B, correct? If I say what is the magnitude of vector A, you will say how much? 4 kilometer. Magnitude of vector A will be 4 kilometer. What will be the magnitude of vector B? You will say 3 kilometer. Simply the magnitude. Now, if I say what will be modulus of A plus modulus of B? So right now we have seen what is the meaning of this notation. It means sum of magnitude of vectors. So it will be how much? 4 plus 3 kilometer. So answer will be 7 kilometer, right? So in this case, the sum of the magnitude of vectors, that is modulus of vector A and modulus of vector B, when you are adding them, it is coming to be 7 kilometer. Okay. Now suppose we have to find the resultant vector. We have to find the resultant vector and say vector R is vector A plus vector B. So in the previous lecture, we have seen what is the physical significance of the resultant vector. Basically, resultant vector is a single vector which will give you the same physical effect, the same physical outcome as given by the number of vectors acting together. The resultant vector is a single vector which will be giving you the same physical outcome as given by a number of vectors acting together. So from O, you have walked up to A, and from A, you went to B. Now, suppose if you don't want to undergo two displacements and you want to have the same physical outcome with a single displacement, vector R, so you'll say, I have to go directly from O to B, correct? This is a single displacement which can be given vector R, which is sum of the vector, which is giving you the equivalent effect, the same physical outcome as given by the two displacements. Now, if I have to find the magnitude of R, suppose if I have to find the magnitude of R, so we know, we have seen many times, the magnitude of any vector means the length of the side representing the vector. So in this right angle triangle, if you write vector R modulus, that is the magnitude, so geometrically you have to find the side OB. Now finding the side OB involves the application of basic geometry, nothing else. Vectors are added geometrically. Again, I'm repeating. The more you are clear with the geometric properties, the more you are clear with vectors. The vectors are added geometrically. So if you're finding the side OB, simply apply the lower class geometry, the Pythagoras theorem. So OB will come to be OA square plus AB square whole under root. So therefore, vector R modulus will come to be, now what is OA? Magnitude of vector A. What is AB? Magnitude of vector B square. So vector R will have a magnitude 3 square plus 4 square under root. So it will be 5 kilometer. 5 kilometer, right? Unit is kilometer. So modulus of vector R is 5 kilometer. Okay. And vector R is this thing A plus B. So instead of modulus of vector R, you can also write modulus of A plus B. Whenever you're writing the modulus of the resultant, you can also write the sum of the vectors because this is simply vector R. So modulus of A plus B will come to be how much? 5 kilometer. Okay, now see the significance. Just see the beauty, how these things differ. What you're doing in this case, you are first adding the vectors. What you're doing in this case, first you are adding the vectors A and B, and you got the resultant vector A plus B, which has a magnitude of 5 kilometer. And when you were adding simply the magnitude, it came to be 7 kilometer. So in this case, you can see when we were adding the magnitude of the vector, it came to be 7 kilometer. And when we are adding the vectors and taking the magnitude, it came to be 5 kilometer. So you can see the modulus of A plus B is not same as modulus of A plus modulus of B. Got it? They have different meaning. So I guess you must be clear now about what is the difference between adding the magnitude of the vector and adding the vectors, then taking the magnitude. Okay? Now see one basic property which will be used in many of the cases. Suppose we have a right angle triangle and this is vector B and this is OAB and this angle is theta. So for this theta, this is base and this is your perpendicular. Suppose theta is known and B is known and we have to find the base and the perpendicular. So you can apply sine theta, sine is perpendicular by hypotenuse, so you'll get OB by AB. So OB will come to be AB sine theta. What will be AB? AB will be simply B, or you can say modulus of vector B, not vector B, because AB is the magnitude of vector B. So OB will come to be B sine theta, correct? So this perpendicular will come to be B sine theta. And when you apply cos theta, base upon hypotenuse, so you'll get OA upon AB. So you'll get OA as what? AB cos theta. So OA will come to be B cos theta, correct? So this will be B cos theta. Now in many of the MCQs or in the fingertip points, you can directly apply this equation. Whenever you have a right angle triangle, and suppose this angle is alpha, and this is vector A. So for this alpha, this is your base, and this is the perpendicular, okay? So on the base, put the cos of hypotenuse, and on the perpendicular, put the sine of the hypotenuse. So base will come to be A cos alpha, and this will come to be A sine alpha, correct? So take this point as a fingertip point, okay? How in a right angle triangle we can find the base and the perpendicular in terms of the hypotenuse. Got it? Now see the Polygon law, the analytical method. Polygon law, analytical method, okay? Now suppose we have three vectors A, B and C and we have to add them and the resultant is vector R. What is the meaning of analytical method? We will calculate mathematically. We will derive the formula or the expression for the magnitude of the resultant and the direction of the resultant, okay? And suppose the angle between A and B is alpha and the angle between B and C is beta, okay? Now if I am applying the Polygon law, I will make the first vector, I will extend the line of the first vector. Suppose this is your vector A. Now vector B is subtending angle alpha with vector A. So this will be alpha and this will be your vector B. Now I can extend the line of vector B, correct? Vector B can have the extended line and vector C is subtending angle beta with vector B. So this is your vector C, correct? So this is O, A, B, C. And vector R is the sum of the three vectors. Vector R is the resultant of the three vectors A, B and C. So Polygon law says when you are representing the vectors by the adjacent sides of the polygon taken in the same order, the resultant will be given by the closing side of the polygon taken in the opposite order, correct? This is your vector R. Now I have to obtain the expression for the magnitude of R and the direction of R. So see, when you are finding the magnitude of R, so geometrically we have seen, whenever you are finding the magnitude of some vector, geometrically we have to find the length of the side representing that vector. Yani we have to find the side OC, correct? Find the length of the side OC. Now see, now we will do some geometric construction and understand the reason for doing a particular construction. If anyhow we can get OC as the hypotenuse of a right angled triangle, I repeat, if anyhow, if by some method, by some geometric construction, we can make OC as the hypotenuse of some right angle triangle, correct? This is my goal. This is my goal. So we can easily find OC by applying the Pythagoras theorem. So what I am going to do, I will do something so that OC may become the hypotenuse of a right angle triangle. And for this, what I'm doing, I'm dropping a perpendicular from C to OA extended. Say this is your R. So now we got a triangle ORC. Triangle ORC is right angle triangle. But there is one problem. There are some sides missing. Before applying the Pythagoras theorem, we have to find the missing sides like this. So say this point is S, this is your T, and this is your V. Now if you see the triangle AST, so this is your vector B, and this angle is alpha. For this alpha, this is base, and this is your perpendicular. So right now we have seen, whenever the hypotenuse is given, the base will be hypotenuse times cos theta, and the perpendicular will be hypotenuse times sin theta. So base will come to be B cos alpha, and this will come to be B sin alpha, correct? So this will be B cos alpha, and this will be B sin alpha. Got it? So we got two missing segments. Now if you see the triangle CUT, triangle CUT, and this is a vector C. What will be this angle, this whole angle? So say this angle is beta. Beta is the angle which C is subtending. Beta is the angle which C is subtending with the vector B extended. And this blue line TU is parallel to AR. So this angle will be alpha. So this whole angle will be alpha plus beta, correct? This whole angle will be alpha plus beta. So now this is the base. So this will be C cos alpha plus beta, and this will be C sin alpha plus beta. Got it? So you got all the missing side. This side came to be C cos alpha plus beta, and this side came to be C sin alpha plus beta. Correct? Now we can focus on the bigger right angle triangle. Now you can focus on the bigger right angle triangle. Which one? CRO. This is your vector R. Now what will be this complete length? So this is A, magnitude of A, plus B cos alpha plus C cos alpha plus beta. And what is this length? So we'll get B sin alpha plus C cos alpha plus beta. Now see, I am making you to understand a generalized case, how the things are derived. The derivation of triangle law will be very straightforward and very easy for you once you understand this thing. So what we did, we have to find the magnitude of vector r. What we did, for finding the magnitude of vector r, we have dropped a perpendicular from C to OA extended. Now we got a right angle triangle, and OC is the hypotenuse of the right angle triangle. But before applying the Pythagoras theorem, we have to find the missing sides. So by applying the basic skill, this one, by knowing the hypotenuse, you can know the base and the perpendicular. We have seen if this is B, this will be B cos alpha, this will be B sin alpha. If this is C, and this whole angle came to be alpha plus beta, so this will be C cos alpha plus beta, and this came to be C sin alpha plus beta. Now, what will be the magnitude of R? That is the length OC. So it will be OR square plus RC square whole under root. So vector R will have a modulus value A plus B cos alpha plus C cos alpha plus beta whole square plus B sin alpha plus C cos, sin, this is sin, I wrote cos, C sin alpha plus beta whole square whole under root. So this came to be the magnitude of the resultant in terms of A, B, C, alpha and beta. Okay, this is what? The magnitude of the resultant vector. Now we have to find the direction of the resultant. So suppose R is this was vector A. So suppose vector A and vector R have an angle alpha between them. That is, a vector R is subtending angle alpha with vector A. So in this triangle, this angle will be alpha. So alpha will tell the direction of R. Remember, the direction of the vector is determined by the angle made by the vector. So the direction of vector R, for this we have to find the angle alpha. So we can apply tan alpha, and tan is perpendicular CR by base OR. So you will get B sin alpha plus C sin alpha plus beta divided by A plus B cos alpha plus C cos alpha plus beta. This will be the value of tan alpha. And of course, you can make alpha as the subject, writing tan inverse. So this is the approach. You need not to remember these end formulae. This is the approach for the derivation, how you are going to derive analytically, how you are going to find analytically, mathematically, the magnitude and direction of the resultant vector using Polygon law of vector addition. Got it? This is the essence which you need to understand. First of all, you are making some geometric construction so that vector R may become the hypotenuse of some right angle triangle. Got it? Now see, triangle law of vector addition. Now see, triangle is nothing but a special case of polygon. We know triangle is a special case of polygon with 3 sides. And we have seen in the previous lecture, if there is n-sided polygon, then how many vectors can be added? N minus 1. So with the help of the triangle law, how many vectors can be added? 2 vectors. 2 vectors can be added. Now, what is our goal? Using the triangle law of vector addition, we will derive the expression for the magnitude of the resultant and for the direction of the resultant. And these expressions will be used directly in most of the problems. So this segment is very important. We will derive the expressions and then we'll also have the expressions on the fingertip. And the derivation will involve the skills which you have seen here. Nothing new. If you understood this skill, then the derivation for triangle law will be very straightforward for you. So suppose there are two vectors A and B, and the angle between A and B is theta, okay? And let R is equal to A plus B. Vector R is the sum of the two vectors. So R is equal to A plus B. Now, if I have to add the two vectors, I will first make the first vector. Say I'm representing the first vector by the side OA. Then I'm extending the line. Now I'm making the second vector. This is vector B. So this is our B. Now I'll make the resultant, which will be the third side of the triangle. This is a vector R. That is same the Polygon law. Here you can say two vectors are represented by the two sides of the triangle in the same order. Two vectors are represented by the two sides of the triangle in the same order. The resultant will be given by the closing side in the opposite order. If two vectors, same language of Polygon law, simply you are changing the number of sides are represented by two adjacent sides of triangle in same order, then the resultant will be third side in opposite order. Okay. And this will be the vector angle. We know how to make the vector angle head to tail, the extended line angle, supplementary angle. Now, goal one, we have to find the magnitude of vector R. That is the first goal, magnitude of vector R. We are interested in the derivation of the expression for magnitude of vector R. And the derivation of triangle law is also important. Sometimes you have to work it out. So for finding the magnitude of vector R, we will have the same goal. We will do some geometric construction so that the line OB becomes the hypotenuse of a right angled triangle. And for this, what I'm doing, I'm dropping a perpendicular from B to OA extended. So this is M. Okay, this is M. Now, before applying the Pythagoras theorem, we have some missing side, AM and BM. And I'm applying the detail approach here. You can, because I'm doing the complete working, BMA, this angle is theta, and this is vector B. So when you apply cos theta, it will be AM by AB. So AM will come to be AB cos theta, and AB is the magnitude of vector B. So it will be B cos theta. And sin theta will be perpendicular by hypotenuse. So BM will come to be AB sin theta. So I'll get B sin theta. So this will be B sin theta and this will be B cos theta. So I got this thing as B cos theta and this thing as B sin theta. Got it? Now I'm finding the magnitude of R. So magnitude means geometrically I have to calculate the length of the side representing the vector, that is OB. So vector R modulus means the line OB, length of the line OB. So in the right angle triangle, you can say it will be OM square plus MB square whole under root. So it will be OA plus AM square plus MB square whole under root. Now what is OA? A, simply A, not vector A. It is the length, magnitude, plus what is AM? B cos theta square plus what is MB? B sine theta square whole under root. So it implies that it will come to be a square plus, we are applying the square of the sum, x plus y square will be x square plus y square plus 2xy, b square cos square theta plus 2ab cos theta plus b square sine square theta, correct? What I can do, I can take b square common, so I'll get a square plus b square cos square theta plus sine square theta plus 2ab cos theta. And we know the basic of trigonometry, cos square theta plus sine square theta is 1. So you'll get a square plus b square plus 2ab cos theta. This came to be the magnitude of vector r. Okay, this came to be the magnitude of vector r. Now there are so many ways for writing this. We have seen the magnitude of vector r can also be written like this, the magnitude of the sum of two vectors a and b. In this case, there are two vectors. So LHS can also be written like modulus of vector a plus b is a square plus b square plus 2ab cos theta. Okay, magnitude on RHS, you can also write like, instead of a, you can write modulus of vector a. Instead of b, you can write modulus of vector b plus 2 vector a vector b cos theta, correct? So there are so many ways, different notations, all are equivalent for writing the magnitude of the resultant or magnitude of the sum of two vectors. Now you can see the magnitude of sum of two vectors depends on the magnitude of the first vector a, the magnitude of the second vector b, and moreover on the angle between the vectors theta. So there is role of theta, there is role of the relative orientation of the vector when you are adding the vectors. That was not the case with scalar. Scalars were added by simple arithmetic, but when you are adding vectors, you have to take into account the angle between the vectors. Okay, this is the magnitude of r, which we will keep as a fingertip point. Now let's see the direction of r. So we know for finding the direction, we will find the angle. So let r makes an angle alpha with vector a. Direction of vector r. So let r makes an angle alpha with a. So if you see the right angle triangle BMO, so tan alpha will be the perpendicular. Perpendicular is b sine theta divided by base a plus b cos theta. So we'll get b sine theta divided by a plus b cos theta. So alpha will be tan inverse b sine theta divided by a plus b cos theta. So this came to be the formula for the direction of vector r, the angle alpha, which it is subtending with vector a. Got it? Now, whenever you are applying the triangle law, when you are adding the vectors according to triangle law, simply apply these two equations. You need not to derive the whole thing again. That's why I say for triangle law, the previous case, this case was generalized case. We need not to remember this end formula. In this case, I wanted you to learn the skill, how we make the geometric construction and why, moreover, why we make the geometric construction. Now, triangle law is frequently used in the problem, so we will have these equations on the fingertip. So whenever you are applying triangle law, we will have a fingertip point. Whenever you are applying triangle law, make the first vector, and remember, the second vector will have a tail at the head of first vector. This is called head to tail, and this will be the vector angle. Now make the resultant by the third side of the triangle taken in the opposite order, that is from O to B. This will be the resultant vector, and say R is making angle alpha with A. So we have seen two things. R will have a magnitude A square plus B square plus 2AB cos theta whole under root, and alpha will be tan inverse B sin theta by A plus B cos theta. Got it? So these are the some points which will keep on fingertip for frequent application. Got it? Now see one illustration. Suppose there is a box and two forces are acting on the box, F1 and F2. And the angle between the forces is 60°, and the magnitude of F1 is 10 Newton, and the magnitude of F2 is say 8 Newton, okay? And we have to find the resultant force, okay? So say the resultant force is F. So F will be vector F1 plus vector F2, correct? This is the notation how we write. And we always write the vector addition like this, no matter whatever be the angle between them. Now if I'm applying the triangle law, so I have to make another figure. First I will make the first vector, say F1. I'm making the first vector F1 by the side say OA. Now I'm making an extended line. Now I'll make the second vector F2, and F2 is directed at an angle of 60° with F1. So this is how we will make according to head to tail figure. Now I have to make the resultant vector. So guess where will be the resultant? Yes, it will be from O to B. Okay, now you have to apply directly the end derived formulae. This is not R. In place of R, it is F. Remember, A, B, and R were the prototype in the model of derivation. Vector A, vector B, and vector R are the vectors used in the model for derivation. When you are applying in any situation, it can be any other vectors. Like in this case, in place of vector A, we have F1. In place of vector B, we have F2. And in place of the resultant, we have what? F. Now you need not to construct anything. Remember, I told you to have the end formula, end expressions of the triangle law on fingertip. We will directly apply the formula. So we have seen R was root A square plus B square plus 2AB cos theta. In this case, what will be theta? Theta is the vector angle. Theta is 60°. So in place of R, I am writing F. In place of A, F1. In place of B, F2. 2F1, F2 cos theta. So F will come to be, what is F1? 10. What is F2? 8. 2 into 10 into 8 into cos of 60°. And we know cos of 60° is half. So F will come to be 100 plus 64 plus 2 into 10 into 8 into half. This 2 will get cancelled away. So we'll get F to be 164 plus 80. So we'll get root 244 Newton. So this is the value of F. This is the value of F. And you can also say this is the value of the magnitude of the sum of vectors, modulus of F1 plus F2. F is the resultant of two vectors. So when F has a magnitude of this is same as the magnitude of the sum of vectors, 244 root Newton. Got it? Now what will be the direction of F? So suppose F is subtending an angle alpha with F1. Let F subtends an angle alpha with F1. So what will be the formula for tan alpha? So in the triangle law, tan alpha was B sine theta. B sine theta divided by A plus B cos theta. In this case, what is in place of B? F2. So F2 sine theta divided by A. What is in place of A? F1 plus B F2 cos theta. So what is F2? How much? So F2 is 8, F1 is 10. 8 theta is 60 degree. 10 plus 8 cos of 60 degree. Now we know sine 60 degree is root 3 by 2 and cos of 60 degree is half. So this will come to be 4, this will come to be 4, this will come to be 4 root 3 by 14. So we'll get 2 root 3 by 7. So alpha will come to be tan inverse 2 root 3 by 7. This will be your answer. This is denoting what? The direction of the resultant force which it is making or subtending with the first force F1. So this is how we apply the triangle law. This is the method how we apply the triangle law for adding two vectors. Got it? Now let's see some of the special cases of triangle law. We have seen when you make two vectors, the tail to tail smaller angle is the vector angle, and the range of the vector angle is from 0 to 180 degree. So see the first case. When the vectors are in the same direction, these are called the parallel or like vectors. Remember, parallel or like vectors. In this case, theta will be 0 and cos of 0 is 1. So in this case, r will be a square plus b square plus 2ab cos of 0 under root. So r will come to be a square plus b square plus 2ab. Now the trinomial can be written as a perfect square, so it will come to be a plus b whole square under root. So in this case, r will come to be a plus b. So this is very straightforward addition, right? This is very straightforward addition. In this case, the resultant will have a magnitude which will be equal to the sum of the magnitude. So you can also write like this. Remember, r can be written like modulus of a plus b, and RHS will be mod of a plus mod of b. Okay. So this is a special case when the vectors are in the same direction. When the vectors are in the same direction, the magnitude of the sum of vectors is same as the sum of magnitude of vectors. We have seen today in the previous slides that these two meaning are different. In vector mathematics, these two notations are different and they are not equal. But in one special case, only in one special case, when the angle is 0 degree. When the angle is 0 degree, the vectors are in the same direction. When the vectors are in the same direction, then you can say modulus of a plus b is equal to mod of a plus mod of b. And the resultant will be also in the same direction. R will also be in same direction. Okay, like suppose we have a box and you're applying two forces on the box, F1 and F2. Both are in the same direction, say F1 and F2, and F1 has a magnitude of 5 Newton and F2 has a magnitude of 4 Newton, and say vector F is the resultant force, that is vector F1 plus vector F2. So in this case, since they are in the same direction, so you can write vector F will have a magnitude which will be denoted by F, or vector F mod simply the sum of the magnitude, F1 plus F2. F1 and F2 are denoting their magnitude. So it will be 5 plus 4 that is 9 Newton. So in this case, vectors are added like a scalar when they are in the same direction. When they are in the same direction, the sum of the magnitude and the magnitude of the sum of vectors are equal. This is one special case, and this is the maximum possible value of the resultant. Remember, this is the maximum possible value of the resultant vector a plus b, sum of the magnitude. You can never get a resultant magnitude higher than this. You can also write like this: mod of a plus mod of b. Got it? So this is the maximum possible value of the resultant vector, and it will be when they are in the same direction. Okay, now let's see case 2. Orthogonal vectors. Or perpendicular vectors. Okay, so suppose two vectors are perpendicular. This is vector A and this is vector B, and I'm extending this line. This angle is 90. So this will be the result R. In this case, theta is 90 and the value of cos 90 is 0. So if you apply the formula of R, R will come to be a square plus b square plus 2ab cos 90, and cos 90 will be 0. So R will come to be a square plus b square, correct? Which you can see directly. Even if you see the direct geometric figure, it is already a right angle triangle. So R is the hypotenuse, which will be root a square plus b square. This can also be written like modulus of a plus b is modulus of a square plus modulus of b square whole under root, correct? Simply instead of R, I'm writing modulus of a plus b, and a and b can be written as modulus of vector a and modulus of vector b. Now suppose this angle is alpha. So see, for finding alpha, either you can apply the complete formula of triangle law, or since this is already a right angle triangle, so there are two ways. Way one, since it is a right angle triangle, you can directly apply tan alpha is perpendicular by base. So what is perpendicular? B, magnitude of vector b, that is b, divided by a, magnitude of vector a. Or way two, apply the complete formula b sine theta by a plus b cos theta. Now in this case theta is 90, so it will be b sine 90 by a plus b cos 90. Now sine 90 is 1, cos 90 will be 0, so it will come to be b by a, same thing. So in either way you can find tan alpha. So this is the second special case, how we can find the resultant vector when both the vectors are perpendicular. Now we will come to the third case, unlike vectors or anti-parallel vectors. Means the vectors are in the opposite direction. So angle will be 180, theta will be 180, and cos of 180 is -1. So let R be the sum of vectors. Always remember, I told you, whenever you are writing R, always write vector A plus vector B, no matter whatever be their angle or direction. This is a notation for sum of vectors. Now in this case, R will have a magnitude a square plus b square plus 2ab cos 180. So R will come to be a square plus b square minus 2ab. So R will come to be, the trinomial can be written like a perfect square, a minus b whole square. So I can remove the under root sign. So it will be a minus b. And you have to take care of one thing. The resultant vector, this is the magnitude of the resultant vector. So the magnitude of a vector can never be negative. So the resultant vector can never have a negative magnitude. So for this safety, we put a modulus sign here. So it will give you the absolute difference. Suppose if A is 5 and B is 7, so inside the modulus, you will get, suppose if A is 5, B is 7. So I'll get 5 minus 7. So I'll get minus 2 mod. And modulus will make it positive, so I'll get 2. So we are putting a modulus sign because the vector can never have a negative magnitude. Now other ways for writing this will be, you can write like this. R is what? A plus B. Remember, LHS is not changing in any case. LHS is same in all the cases. It will be modulus of A, magnitude of A, minus magnitude of B, whole mod. Correct? And what will be the direction? So the direction of resultant will be in the direction of greater magnitude. Whichever vector is having a greater magnitude, the resultant will lie on that side only. So suppose if you have a ball, and two forces are acting, F1 right side, F2 left side, F1 is 8 Newton and F2 is say 10 Newton. And the resultant force is F. So when you are writing the vector equation, what you will write? Vector F1 plus vector F2, vector F1 minus vector F2, vector F2 minus vector F1. What do you think? When you're writing vector F, which will be the correct option? Vector F will be vector F1 plus vector F2, vector F will be vector F1 minus vector F2, or vector F will be vector F2 minus vector F1. Think and answer. Just think for 1 minute and answer. Here both the vectors are in the opposite direction. So what will be the notation for writing the resultant vector? Well, we have seen no matter whatever be the direction of two vectors, no matter whatever be the angle between the two vectors, when you are adding them, the notation will be the sum of the vectors. This. So the notation of F will be vector F1 plus vector F2. That is, vector F is a single vector which is giving you the combined effect of two vectors. Now in this particular case, the two vectors are in the opposite direction. So when you're writing the F, since they're in the opposite direction, now I'm not putting the vector sign. This is the magnitude. So you can write modulus of F1 minus modulus of F2. Again, these are the magnitudes. So F1 is 10 minus 8 mod. Answer will be 2 Newton. This is the resultant force magnitude. Now where the resultant will act? What do you think? Where the resultant will act? It will be on the side of greater magnitude. So it will be like this, on the side of F1. The net force will act on right side. Okay. So we have seen three special cases. That modulus of A plus B. And one more thing, this will be the minimum possible magnitude. This is the minimum possible magnitude between the two vectors. The resultant will have minimum magnitude. As the absolute difference of the vector. So we have seen three cases. When the angle is 0 degree, modulus of A plus B comes to be A plus B. When the angle is 90 degree, modulus of A plus B comes to be A square plus B square under root. And when the angle is 180 degree, modulus of A plus B comes to be the absolute difference of the two vectors. Now, this is the maximum possible magnitude, and this is the minimum possible magnitude of the resultant. So you can say R will lie between A plus B and A minus B modulus. Or you can say modulus of A plus B. R can be written like this. Remember, R is the magnitude of the resultant. That is, magnitude of A plus B will lie between A plus B and A minus B. This is the range of the magnitude of the resultant vector. Got it? So suppose if I say two forces are acting on a ball, F1 and F2, and F1 is say 10 Newton and say F2 is 7 Newton, and F is the sum of two forces. Correct? So if I say, tell me what will be the value of F, what will be the magnitude and direction of F. So can you tell me the magnitude and direction of F with this much information? Do you think this much information is sufficient for telling the magnitude and direction of F? No, because we have seen while adding the vectors, we have to take into account three quantities, three parameters: the magnitude of the two vectors and the angle between them. So the angle is missing. So we can't tell the value of it. It depends on the angle. But if I say, can you tell me, whatever the angle may be, can you tell me the range of F, magnitude of F, the range of magnitude of F? Yes. You can say the maximum magnitude of the resultant will be sum of the individual magnitude, that is 10 plus 7, that is 17 Newton. And the minimum possible magnitude of the resultant will be the absolute difference of the magnitude, that is 10 minus 7, that is 3 Newton. So whatever be the angle, no matter whatever be the angle, take any angle of possible angle, the F will have a range 17 Newton and 3 Newton. It can never be greater than 17 Newton. It can never be greater than 17 Newton, and it can never be less than 3 Newton. When it will be 17 Newton, what do you think? When, in which case it will be 17 Newton? When the angle will be 0 degree, both the forces will be in the same direction. When it will be 3 Newton, when the angle is 180 degree, both the forces are in the opposite direction. Got it? So we have seen three special cases, and take care, in all the cases, LHS is not changing. Can you see? LHS is modulus of vector A plus B. In all cases, it is giving you the magnitude of the sum of vectors. RHS is changing depending on the angle between the vectors. Okay? Okay, now let's see ahead. See, one of the basic property of triangle, which you must have studied in lower classes and which will be quite helpful in solving the problems of vectors, especially MCQs. Suppose this is A and this is B and this is R, and say this angle is alpha and this angle is beta. Okay. So out of A and B, which angle will be greater? So with the smaller side, the angle will be greater. Remember, angle will be greater with smaller side. Okay, this is the first property which we will use in vector problems. Okay, so if, what will be this side? Your OA will have the magnitude of vector A, and AB will have a magnitude of vector B. So alpha will be greater than beta if A is less than B, correct? With the smaller side, angle will be greater. So alpha will be greater than beta if A is less than B. Remember this thing. So if I say, if I apply the triangle law, and say this is your vector A, and this is a vector B, and this is the sum of the vector R. R is A plus B, correct? And R is subtending angle alpha with vector A and angle beta with vector B. This will be angle alpha, vectors are tail to tail, so the smaller angle will be vector angle, and in this case the vector are head to head, so smaller angle will be the vector angle. So the resultant of two vectors is subtending angle alpha with vector A and angle beta with vector B. Now which option will be correct? Alpha will be equal to beta. Alpha will be greater than beta if magnitude of A is greater than magnitude of B. Alpha will be less than beta if magnitude of A is greater than magnitude of B. And option D, none. So what do you think? Which option will be correct? Simply apply the basic property of the triangle. With the greater side, the angle will be smaller. They will not be equal unless both will have the same magnitude. This is a special case. We will see this is not a generalized case. This is a special case. It is possible, but when both magnitudes will be equal. Now, if magnitude of A is greater than magnitude of B, then the angle of A with A will be smaller. So this option is incorrect. If magnitude of A is greater than the magnitude of B, then applying the basic property of triangle, alpha will be less than beta. Because if A is greater than B, A will be a greater side. So angle with A will be smaller. So option C is the correct option. Okay. And when you think when alpha and beta will be equal, when alpha is equal to beta, when modulus of vector A will be equal to modulus of vector B. In this case, when both the vectors are of same magnitude, this is a special case. When both the vectors are of same magnitude. These are very fingertip points for your MCQs. Okay, so if both vectors are of same magnitude, so this angle and this angle will be equal. So if this is alpha, then this will also be alpha. And this is your special case. And if this is the vector angle theta, so by applying the basic property, the exterior angle is equal to the sum of the interior opposite angle. So alpha will be theta by 2. So whenever two vectors have the same magnitude, remember, suppose if you're adding two forces, okay, and F1 has a magnitude of 10 Newton, and F2 is also having a magnitude of 10 Newton, and say theta is 60 degree. So many of the things you can tell without calculation. You can make the figure. This will be F1, this will be F2, this will be 60 degree, this is resultant force, and these both angle will be equal. F will be equally inclined. The resultant will be equally inclined with both the vectors. And what will be this angle? Half of this angle. 30 degree, 30 degree. Got it? So both the angle will be equal. This is a special case when vectors have the same magnitude. Then the resultant will be equally inclined with both the vectors. Otherwise, it will make the greater angle with the vector of a smaller magnitude. Now say if we have two vectors of equal magnitude, and before derivation of this formula, let me tell you one trigonometric equation. If you write 1 plus cos 2 theta, it will come to be 2 cos square theta. The angle becomes half. So if you're writing 1 plus cos theta, see in this case it was 2 theta, so it became theta. In this case it is theta, so it will become cos square theta by 2. Like 1 plus cos x will be 2 cos square x by 2. And 1 minus cos 2 theta is 2 sine square theta by 2. Sorry, theta, half angle. So 1 minus cos theta. Now here 2 theta became theta. So theta will become theta by 2. 2 sine square theta by 2. So like we have 1 minus cos x. So it can be written like 2 sine square x by 2. So suppose if you have something under root 1 plus cos x. So it can be written like 2 cos square x by 2. Okay, this is something basic maths trigonometry which you can write it down because we will use it in many of the problems. Now see, we are adding two vectors of same magnitude. We are adding two vectors of same magnitude. Let r is equal to a plus b, and modulus of a is same as modulus of b. They have the same magnitude. Or you can also write like this and say angle between a and b is theta. So when you make the triangle, you will make the two vectors head to tail. Both will have the same length. The triangle will be isosceles, and this angle will be theta, and this will be your resultant vector, right? So see, when you write r, magnitude of r, it will come to be a square plus b square plus 2ab cos theta whole under root. So in place of b, I can put a because b and a have same magnitude. So a square plus 2aa cos theta. So I can take 2a square common, 1 plus cos theta, correct, under root. So we'll get a 2 1 plus cos theta. Now I will use this trigonometric formula. 1 plus cos theta will be 2 cos square theta by 2. 2 cos square theta by 2. So therefore r will come to be a 2 cos square theta by 2. So r will be, no, this will be outside 2a cos theta by 2. So this is the resultant magnitude when two vectors have the same magnitude. And a is the common magnitude. A is what? Common magnitude, and theta is vector angle. And what will be this angle? Already we have seen, since these two sides are equal, this angle will be equal, and both angle will be half of the vector angle, theta by 2, theta by 2. So this formula you can directly apply. This is a fingertip formula which we can directly apply when the vectors have the same magnitude. You can apply this formula only when two vectors have same magnitude. Like suppose I'm adding f1 plus f2, okay, and the magnitude of f1 is same as the magnitude of f2, say f0. An angle between f1 and f2 is say 60 degree. So I can make the figure. We have a special case here. Both the vectors are of same magnitude. So when I make the figure, I will make first vector f1, second vector f2, then I'll make the resultant vector f, and since they have the same magnitude, it will be isosceles triangle, and this angle is how much? 60 degree. So first of all, you can write what is the angle between f and f1 or f and f2. Simple geometry. It's a special case of same magnitude. It's a special case of same magnitude. So this will be half of the vector angle, 30 degree, correct? And now I can apply the special case formula. Same magnitude, resultant is 2 multiplied by common magnitude, which you can write f1 or f2 cos theta by 2. What is theta in this case? The vector angle 60 degree. So f will be 2 f0 cos 60 degree by 2. So f will have a value of f naught cos of 30 degree. So f will have 2 f naught root 3 by 2 to get cancelled away. So your answer will be f naught root 3. So this is how you can apply the resultant formula and the resultant angle when the two vectors have same magnitude. When the two vectors have same magnitude, the resultant will be 2a cos theta by 2. A is what? The common magnitude of both the vectors. Theta is what? The vector angle. Got it? So in many of the problems in electrostatics, mechanics, vectors, gravitation, we encounter problems where two vectors to be added have the same magnitude. So you can directly apply this formula. Now see one special case. We know in mathematics, in arithmetic, if I say, is it possible 5 plus 5 is equal to 5? In arithmetic, is it possible that 5 plus 5 is equal to 5? You will say no, never. In fact, we know 5 plus 5 is 10. But in vectors, is it possible if two forces are acting, F1 and F2, and both are having same magnitude, 5 Newton, and F is the resultant of forces, and F will also come to be 5 Newton. Is it possible? You'll say yes. In vector, it is possible. In vector, it is possible that two forces of equal magnitude or two vectors of equal magnitude give a resultant which will also have the same magnitude. Like two forces of 5 Newton each will give a resultant which will also have a magnitude of 5 Newton. And we will see the condition for this. So I'm telling you two approach. Approach one is the geometric approach. Okay, approach one is the geometric approach for solving this problem. So say R is the sum of two vectors, correct? And given magnitude of A is same as the magnitude of B is same as the magnitude of R, correct? That is the thing. Both the vectors have the same magnitude. The vectors to be added have same magnitude, and resultant also have the same magnitude. Now we know triangle law says if you're adding three vectors, the two are made by the adjacent sides of the triangle in the same order, and third is made by the opposite side of the triangle. Now if they have the same magnitude, if all three have then triangle will be what? You will say equilateral, correct? Because all three length will be same. Length denote what? Length denote the magnitude. So if all three have the same magnitude, the triangle will be equilateral. So say this is your vector A, this is your vector B, and this is vector R. And all three have same magnitude. This is according to the information or demand of the problem. So this angle will be 60 degree, this angle will be 60 degree, and this angle will be 60 degree, correct? Now I have to tell what will be the angle between two vectors. What will be the angle between two vectors? That is A and B. So what do you think? What will be the angle between A and B? Will it be 60 degree? Angle between A and B. Will it be 60 degree? Yes or no? Correct. No. Because they are head to tail. And remember the basics. Whenever the vectors are head to tail, we have to take the exterior angle, the supplementary angle. So this angle will be 120 degree. So this will be your answer. Correct? This will be your answer. And you remember this thing for MCQ. If there are two vectors, if R is equal to A plus B, and all three, A has the same magnitude as B, has same magnitude as R, then the angle between A and B is 120 degree. So suppose if I say there are two forces F1 and F2 and both have magnitude of 10 Newton and the resultant also has a magnitude of 10 Newton. Suppose this is your MCQ and you don't want to waste any time. So what will be the angle between F1 and F2? So you remember this thing, this will be 120 degree, okay? So this is how we have solved the problem geometrically. That is your first approach. We have made the equilateral triangle and we have seen the angle. The second approach will be analytical method, mathematical calculation. Approach to analytical method. We will make nothing. We will simply calculate. So let R is equal to A plus B. And the magnitude of A is same as the magnitude of B, is same as the magnitude of R. Say X. All three have the same magnitude. Right now we have seen when you are adding two vectors of same magnitude, when you are adding two vectors of same magnitude, A is equal to B, then the resultant has a magnitude 2A cos theta by 2. Remember, right now we have seen this thing, na? When you are adding two vectors of same magnitude, the resultant has a magnitude of 2A cos theta by 2. A is the common magnitude. So in this case, A is equal to X and also R is equal to X. In this particular problem, A and B are equal, both say X, and R is also having the same magnitude X. So if you put X is equal to 2X cos theta by 2, so X will get cancelled away. So we'll get cos theta by 2 as what? Half. And which angle has a cos of half? Cos of 60 degree. So cos theta by 2 came to be cos of 60 degree. So theta by 2 comes to be 60 degree, so theta comes to be 120 degree. The same answer which you got by geometric approach. And of course the answer must be same. If you're changing the approach or way, the answer will not differ. So if two vectors of equal magnitude has a resultant which is also the same magnitude as either of the vector, the angle will be 120 degree. Okay. So this is all about your lecture 4. Now in the next lecture, we will see some more problems on triangle law and we'll see one very special case when the resultant will be perpendicular to one of the vector. This is also very common, frequent application in MCQs. We'll see the basic property, how we will solve this geometrically within couple of seconds, okay? When resultant is perpendicular to one of the vector, then how we can find the direction of the vector and how we can relate the magnitude.